subject basic electrical engineering, and so far we have discussed about the following topics: three-phase induction motor, rotating magnetic field, single-phase induction motor, DC machines. In our today's session, we are going to discuss about alternators. So, our job is to discuss about the construction of alternators, working principle of alternators, and types of alternators. So, first we check the phenomena of alternators. So, from this alternator working principle is same as the DC machine, right? So, once we check here, when the rotor rotates, the stator conductors which are fixed are cut by the magnetic flux, hence they have induced EMF produced in them. So this is nothing but the principle of electromagnetic induction, Faraday's law. So here, when these two magnets are getting energized, this will produce a magnetic flux around it, and because of this magnetic flux, the current would be passed through in this conductor, and because of this will induce EMF, and because of this induced EMF, finally it will exert the force, and that exerted force in a rotational direction, in a circular motion. That's why this particular conductor is going to now rotate. So this alternator we are using to convert one energy into another energy. So from this you can check this conductor is continuously rotating with this N pole and S pole, and that will generate the EMF. So from this you can check, this will convert it into a DC voltage. From this we can say here, because of the magnetic poles are alternately N and S, they produced an EMF, and hence current in armature conductor which first flows in one direction and then the other direction. So an alternating EMF is produced in a stator conductor because whose frequency depends on the number of N and S poles moving part of conductor in 1 second, N whose direction is given by Fleming's right hand rule. So from this this is what the working principle of the alternator. And if we discuss about the construction of alternator, then alternator being synchronous type machine, field winding are on the rotor, and armature winding is wound and placed in a stator slots of suitable shape. Now on suitable shape. Now here you can check, this is a very important statement. In a part of the DC machine where the armature winding is wound over a rotor and field winding is wound over a stator. So this is exactly a reverse case of DC machine, the construction of DC machine. Here, when the field winding and rotor is connected to an external DC source through a pair of slip rings as shown in figure. So you can see this. This is the prime movers where that will provide the mechanical energy, and finally that will convert it into electrical energy. So here the armature winding is wound over this stator, and here there is a part of the field winding which is wound over the rotor. From this you can see the slip rings, a pair of slip rings are available from this particular figure. So from this you can check here, the inner part is the rotor part, and where the rotor windings are available in form of the field winding, and outer part that is available in a armature winding. So here you can see these are the different slots of this a part of the stator. This is the stator frame. Inside there is a rotor, and these are the slip rings. So this is just the front view of this alternator. So here the armature winding is three-phase winding on stator, and induced voltage in this applied to the load as three-phase AC voltage produced a rotating magnetic field. So this will again produce a rotating magnetic field. So here the prime movers or motor or diesel generator is mechanically coupled to the shaft of the machine, and it is used to rotate the armature. Speed is called the synchronous speed of NS, where the stator frame is made up of the cast iron to support the stator core with slots in its inner periphery in order to hold the stator conductors. So from this let us first discuss about the stator. So this part is the stator, the outer part is defined as a frame, the inside this is the static part where the armature winding is available. So yeah, this you can see the wound over the armature winding. There are different slots over this stator. So here the stator is stationary uh, armature consists of a core and slots to hold the armature winding, here constructed using the laminations. So the eddy current losses are small. Core is fabricated in a frame made of steel plates which slots on its periphery, and armature conductors are mounted in these slots. So frame provides a support to core, but it does not carry the flux. So holes are cast in frame for the ventilation. So you can see this are the small holes are available for the ventilation purpose. So this is a complete portion as a the part or the construction of the stator, where there are in this particular stator you can check there are the different slots are available. We can consider as a tooth, and outer part of this slots or teeth you can check there is a field winding, sorry, there is a armature winding is bound over it like this way, right? So this is what the construction of stator. Now discuss about the construction of the rotor. Before that, we learn about the two types of rotors are used in alternator. So if you talk about the part of the rotor, where there are two types of rotor are available in a alternator, when one type of rotor we define as a salient pole rotor, and another part of the rotor we define as a smooth cylindrical type of rotor. So this is the outer part of the this alternator, that is the part of the stator, right, where we just discussed about the stator. Along with that there is a field winding, but here along with that this is the armature winding, but here you can see the lower this particular portion we define as a rotor, right, where the pole pieces are available. These are the pole pieces are available at different locations, and around it there is a wound of the field coil, right? So this is a part of the rotor, where this type of rotor are available in a available in a two forms. One form we define as a salient pole type, and another form we define as a smooth cylindrical type. So now let us discuss separately the salient pole type of rotor and smooth cylindrical type of rotor. So first we discuss about the salient pole type of rotor. So it is used in low and medium speed engine driven alternators. It has a large number of projecting salient poles having their cores bolt on a heavy magnetic wheel of cast iron or steel of good magnetic quality. So this is the construction of the salient pole. You can check this is the part of the shaft, where this R we define as a bolt, and around this bolt this particular projecting poles are fixed on this bolt. Around this you can check this shaded part. Around this there is a field winding, and this it will give the mechanical support to this bolt, and this is the complete portion of the rotor, which is continuously moving either in a clockwise direction or in an anti-clockwise direction in a alternator, where you can check this low and medium speed application. We can use this kind of rotor, which define as a projecting poles. So this poles we define as a salient pole, right? Further we discuss about this type of rotor, where such generators are characterized by their large diameters and short axial lengths. So the poles and pole shoes are laminated to minimize heating due to the eddy currents. In large machines, field winding consists of rectangular copper strip wound over a edge. So right now it does not have the greatest level of mechanical strength. So if you count the rotational per minute, which is called RPM of this rotor, which is not so high. Why? Because it is fixed with this bolt mechanism, where the mechanical strength is not that much high, right? So after that we learn about the smooth cylindrical type, which is made up of a single material. So here in a silent pole type of you can see all the parts are discrete, where it is constructed and fixed through the bolt. But this is not case with the smooth cylindrical type rotor, where it is used for steam turbine driven alternators, turbo alternators, which run at very high speed. So rotor consists of smooth solid forged steel cylinder having a number of slots milled out at intervals along the outer periphery and parallel to the shaft for accommodating field coil. So you can see the complete cylindrical rotor is made from a single material with these slots. Now between these slots you can check there is around these slots there is a field coil is wound around it. So these are the extended poles, you can check, right, which is made up of the same material. These are the supporting poles, and in between you can check the field windings are wound over it where it is excited with the DC supply, right, and this middle part is defined as a shaft. So ultimately this is a rotor which is rotating in a clockwise direction or maybe anti-clockwise direction, but it is made up of the single material, so the mechanical strength is very high, right, so that we can use for a high speed application. For such rotors are designed mostly for 2 poles or 4 poles turbo generators running at 3600 rpm or 1800 rpm for 2 or 4 regions corresponding to central polar areas of the left unslotted. So it should be noted that in this case the poles are non-salient and they do not project out from the surface of the rotor, right. So this we use for a high speed applications. From this now let us compare this to silent pole alternator and cylindrical pole alternator. So poles are projecting out from the surface. Here unslotted portion of the cylindrical acts as a poles, hence poles are not projecting. Poles are non-projecting. The air gap is non-uniform, while here the air gap is uniform due to the smoothly cylindrical peripheral, right. Same way here in a silent pole the diameter is high and the axial length is small, but here the small diameter and large axial length is available in a cylindrical pole type of alternator. Here it is mechanically very weak, or it is mechanically weak in silent pole type of rotor, but cylindrical pole is mechanically strong. Here the silent pole is preferred for low speed alternators, while cylindrical pole prefer for the high speed alternators. Here in a salient pole the prime movers used are for the rotor IC engines, but in a cylindrical type pole rotor the prime movers used are steam turbines and electric motors. Here for the same size the rating is smaller than the cylindrical type, but in a cylindrical pole alternator for the same size the rating is higher than the salient pole of type. Now in a salient pole type of alternator the rotor is also called as a projected pole type, while here this rotor is also called as a non-salient or non-projected pole type in a cylindrical pole alternator. This is preferred for low voltage alternators ranging from 125 rpm to 500 rpm in the case of salient pole alternator, but here it is available or it is preferred for high speed alternator ranging from 1500 rpm to 3000 rpm for a cylindrical pole type of alternator. Now this is what the comparison of these two alternator. For a low speed application it is advisable to use the salient pole alternator. For high speed application it is advisable to use the cylindrical pole alternators, right. Thank you dear students. If you find any difficulty please write in a comment box. Thank you very much.